Okay, we are going to go and start our next presentation, OpenRMC increasing the role of rack manager in data center management. And Han from Meta and Brian from AMI will be presenting. So go ahead, guys. Thanks.
Okay. Oh, that's loud. Thank you very much. Last day of the conference. I hope it's all been great for you guys. Han has been leading this OpenRMC for, I think he told me, almost 6 years or over 6 years. I recently joined to kind of help him out, so the two of us are now the co-leads for this. Today we're going to give you kind of a little bit of history on OpenRMC, in case some of you don't know what that is. But we're going to spend hopefully the most of our time on some of our beliefs that the rack manager can play a much larger role in data center management, especially as we move to more and more disaggregated hardware. So, quick overview of what rack management is, again, for anybody that's new to this. We are not in OpenRMC prescriptive of the hardware or the software for that matter. The hardware can run a lot of different places. It can run inside a power shelf in some cases. I've seen it in top of rack dedicated devices, top of rack management switches. We even have some customers who want to put it inside the BMC and just have one of their BMCs become the, I'll call it the +1 for the entire rack. It can run in firmware or software. So it could run on an x86 or ARM, general purpose server as like a container, or it can run on a traditional BMC silicon. But its main point is that it aggregates all the devices for that rack or pod as under a single management service. So it does all your proxy, all your aggregation. And like I said, hopefully in the future it does a lot more than that. The first bullet here is probably the most true of this slide. I took this off of our wiki page. So most of our time we spend talking about the specification, what we call northbound of the rack. So the Redfish APIs that your traditional data center management software will talk to through the rack manager. We do talk, though, a little about southbound, so how it talks to all the devices. And there is a open source contribution based off of the old device manager that we have done, and there are a few hardware contributions as well. But again, the majority of our focus is the kind of northbound APIs. A little bit on the history. Han can probably speak to this better than I can, but the first OpenRMC 1.0 was released back in 2021, and then 1.1 came out in 2023. This slide is not, when I wrote this, I thought we would have something ready for contribution. We're not quite there, but we'll be there very soon. But the 1.2 will focus on telemetry and composability. So, that should be out definitely before the end of the year. And then kind of our final, maybe not totally final, but our next planned Redfish release, 1.3, I'm going to talk about a little bit more here in the next couple slides, but focuses on multiple layers of aggregation, because now we're seeing with more and more disaggregation, a single rack manager might be too low in the device to truly manage it. But, and again, the focus of this presentation will be on the RMC 2.x, which is our next gen AI infrastructure management, and Han will be talking a lot about that and what Meta has plans for. Okay, so a little more on the evolution of the rack. This is not news to anybody, but legacy racks were typically just a bunch of compute and switch, maybe some storage. And you may have had a rack manager there, but its purpose was more just to help management scale, just to help create layers of aggregation and help your management software scale quickly to tens or hundreds of thousands of nodes. When disaggregated racks came around and you had these AI racks that have scale-up switches and compute, power shelves, and cooling, a lot of the traditional power supplies and fans moved out of the compute chassis, but still stayed in the rack for the most part. Usually you'd have an in-rack CDU that could cool it if you're liquid cooling, and you have the power shelves outside the chassis but still in the rack. And a lot of our 1.2, 1.1 and 1.2 focus is around that. But now we're seeing more and more disaggregation even outside of the rack. So I saw over, I think it's Flex has a demo where they have 3 racks basically as one AI system. One of them's a CDU, one of them is just strictly power, and then the third is your compute. there's probably going to be a day where maybe even some of the switching, the scale-up switching moves outside of that rack, and you could have 3, 4, 5 racks just for a single system. Because of that, a single rack manager now cannot see the power, cannot see the CDU management. So we've got this idea of a pod manager, which adds another layer of aggregation that will help you manage that rack. And I realize that pod manager is also kind of the name that was given to some of the scale-up fabric management. So this pod manager, think of as almost like a row management or a second layer of aggregation. And we may need to come up with some new naming for that or clarify the difference between the two pod managers. But the whole idea is this pod manager now oversees the entire AI system as it's scaled up, including the power and including all the thermal. As a result of that, I don't know, that there's gonna be some changes needed to Redfish to better comprehend this. First of all, we've got it, and we'll add this to the OpenRMC spec. You have to have these multiple layers and how you might talk to a pod manager and have it talk to a rack manager, and then down to the nodes itself, and how all that gets aggregated together. With it disaggregated power outside the rack, that power might need liquid cooling itself. The bus bars might need liquid cooling. So we just have to comprehend all of that with the Redfish models. And they may be there, we just need to understand them and make sure that it does what we need. And then, like I said, liquid cooling management for power. So that's kind of, the 1.1, 1.3 releases. I think the next thing we're really wanting to focus on is where intelligence is in this infrastructure. When I say intelligence, I don't mean just data going up, aggregating and flowing up and flowing down, but the devices that actually make decisions when a critical event or telemetry or something is predicted that take action. Historically, that was down at the BMC level, but as I mentioned, sometimes the BMC doesn't have knowledge of power, it doesn't have knowledge of thermal, so there's a lot of cases where the BMC of the compute node now can't make that decision on what to do in case of an event. It's also done at the data center manager level, but as you scale to tens or hundreds of thousands of nodes, and with the high thermal and power problems of AI, the data center manager is not going to be fast enough. It cannot manage hundreds of thousands of nodes and very quickly, within milliseconds, react to these critical things. So our belief is that the intelligence and the AI could be running at this pod and RMC level. There's a few reasons why. It does provide some flexibility in your design. With these rack managers, you can have failovers, and you can put them anywhere you want in the rack. So it creates some flexibility there. It's probably more cost effective than trying to beef up all of your BMCs inside the rack. You can pay for more expensive BMC silicon or x86 or ARM silicon at one point in the rack instead of having to pay for it all up and down the rack. And as I mentioned, it's going to be your highest performing because it's so close to the rack. It's high enough in the stack that it understands the whole AI system and has enough telemetry to make a decision, but it's not so far up that it can't be responsive in time. So for kind of those three reasons and more, we're hoping that more and more intelligence goes into the rack manager beyond just being a Redfish aggregator. This last session, if you attended that, was some good examples of what the rack manager can do, processing things like crash dumps and real time as they happen, and then taking action right there. So now I'm going to hand it over to Han, and he's going to cover what Meta is doing.
All right, thank you, Brian. So, hello everyone, good afternoon. So my name is Han Wang, and I'm currently with Meta hardware infrastructure team. So I'm also a co-leader of the OpenRMC project. So I would like to share some experience, and also just as Brian talked about, so we right now gradually position RMC as a sweet spot, as an intelligent engine for DC AI infrastructure, lower level hardware management. So probably you heard from the keynote, so over clustering scale size already migrating to multi-million accelerator over multi-regions. So for single AI workloads, we have to maximize work done by the cluster, and we also need to maximize efficient training time, the utilization. So as the keynote says, so there are hundreds of billion capex already invest. So imagine a teeny tiny percentage of efficiency improvement will bring the billion-dollar scale cost benefits. So for the AI infrastructure, we have to minimize cluster integration, and also we must minimize interruption, because as we know, all the AI workload info is less tolerant to all kinds of interruption, very sensitive. So there's, in this case, there's a lot of cost impact. So we have to majorly handle all the hardware interruption using lower level hardware management, typically for compute accelerator, memory link, and storage. So that's why we gradually position RMC as the intelligent engine to help us to drive this effort. So last year we introduced the future RMC role is from really passive rack management controller to our future proactive approach. So we defined the three phases. The phase one is still the legacy hardware management and focus on profile, very basic management control. The phase two for now is so the management should be able to analyze and get predictive. So phase three is the future. So we'll address the AI info requirement. So basically the ultimate goal is be able to automate the optimization and then make intelligent decision. So over the last year to this year, so as Meta, we invest and put lots of efforts to build lots of model and engine to able to analyze and get predict for different areas. So we are continue to this effort to try to get our model optimized and getting more data and understand more error pattern failure modes to prepare for the phase three. Yeah, so just a little bit sharing on a use case. So yesterday I did on the AI and the machine learning track, introduce the experience regarding how to enhance optical link reliability by a proactive approach using machine learning. So the experience is we position RMC as a sweet spot as an intelligent engine to perform early failure detection and prediction for optical link reliability. So, so the results is pretty good. So we are working very aggressive to push a limit. So this engine help us to, for the first half of this year, to achieve significant link failure reduction. So of course, this will bring the TCO benefits. So for our scale, it's easily be $1 billion scale, and potentially could be more if the scale keep going high. So I use this just as a quick example, but so our expectation on this is to provide even more comprehensive coverage on all the use cases. As Brian says, so the role of the RMC or maybe part manager is for DC AI info is got upgraded. So we are not just looking at a traditional way, we are expecting more. So I think call to action. So I think in this talk, we already get update on the spec 1.2 and provide some guidance on 1.3. And the main focus is to talk to the community that we do see increased role of the RMC for future DC AI infrastructure. So I do see a lot of opportunity for our phase 3 features. So the business opportunity not only include just chipset or assistant level design, but also software and intelligent engine kind of design. Lots of opportunity over there. So please feel free to join us to think and design for big things, very, very big. So I think in the end is please feel free to join our subject call monthly and to provide feedback, use cases, or maybe your proposal. We can collaborate to maybe provide the data on top of your contribution because we have a lot of data. And also you are more than welcome to reach offline for further discussion. I think that's pretty much it for today. Thank you.
Okay, let's thank our speakers. We do have time for questions, so go to the mic and ask your questions. Go ahead.
Oh, hey, I'm Justin York. I have 2 questions. The first is, with your architecture, did I hear you say that the nodes within the rack that are being managed by the RMC typically don't have any communication outside to other infrastructure? Is it all just sourced through the RMC?
Well, I mean, you went, okay, thank you. Are you asking if outside management software can access, directly access the BMC? Or if the BMC can go out and access other?
The first.
The first.
Can other infra still talk to the BMC, do like attestation, et cetera?
Yeah, I mean, that's a network decision, but usually yes. I mean, in smaller environments, the management software will just directly talk, and there won't even necessarily be a rack manager in the middle. So, but there are some, I know some of the bigger environments where security becomes a concern. There are some devices that can be in the rack that maybe aren't of the highest security, and therefore they kind of want to sever the outside access in. But that's just a networking thing. I mean, that's just turning it into a firewall and making the rack more of a private network. But yes, absolutely, management software can clearly talk to a BMC.
So that makes my second question less important. But I was wondering if having something at the rack level with a bigger kind of domain leads to any availability concerns, if you have to do any type of thinking around failover or high availability planning.
Yeah, for sure. I mean, if Han and I get our way and the rack manager becomes more intelligent and more responsible for making critical decisions, then it becomes a component that you cannot have fail. And so both with firmware and software, if you built like a container that has your rack manager, there's lots of options for failover in that case, of course. I've seen some designs where a top-of-rack management device has 2 DCSEMs, for example, and those will both act as the rack manager and one will fail over to the other. So failover still is critical, even though, like you said, the management software can still get to the nodes, because maybe that's then not doing some of those decisions that need to be made.
I probably add a little bit. I think right now this is still open. Really depends on the topology, whether you want how much failover and how much distributed you want RMC, right? Depending on how strong the capacity the RMC chipset can deliver, or you have even an offload engine inside RMC, right? So in terms of the hierarchy, so are we gonna level a flat, or we have the bi-part architecture? So it's still open. So we don't want that one to be fully locked on. We want to have sufficient flexibility on that one. Yeah. So this is an open question we need to address. So I think there's no fixed answer for that. So, yeah.
Sorry, the light's really bright. I can't even see you.
Yeah. Can you hear me?
Yes.
Okay, couple of questions. The first one, today's the RMC, whatever it's the upstream, how many racks it can manage? So in the picture you just showed for one rack, but for practical purpose, how many racks it can manage? That's question number one. The other question, you brought up the pod manager. So the pod manager is going to be part of the same work group, or are we going to have a specification for the pod manager, or what's the plan for it?
So let me make sure I understood your first question. Are you talking about the upstreamed OpenRMC device manager? How many racks can it manage?
Yeah, that's
So today, it's my understanding, you would probably know it better than I do, but it's meant for just a single rack. And so it's just managing all of the devices, 40 some maybe devices in that rack. It itself is not managing the racks themselves, the individual racks. You would need another layer like a pod manager or some data center manager to manage all of those racks. So its limits are, 1 or 2 racks at most.
Yeah, I want to add it in more. So the Legacy way is one dedicated RMC for rack. But as I said, so because the trend is we have more and more telemetry need to be collected and more operation. Actually, we want offload to the RMC side. So there's leave an open door to have a more powerful chip. So we don't have to stick to say, hey, one RMC physically, I would like to put it into the rack. We have more freedom here. So that's why we want to have a very flexible architecture choice, right? So in terms of in future, if you want furthermore intelligence, you have more use cases. I think from architecture, we are really flexible. Yeah.
And if I understood your second question, the pod manager will just be, the pod manager is just a rack manager, if you will. So I would think the pod manager and the rack manager would be the same sub-project group that Han and I are running. So we will just add requirements for a pod manager on top of the rack manager, and it'll all be one user guide.
So that'll be a new effort, right? The pod manager one?
I'm sorry?
The pod manager one it'll be a new effort, is it right? Or do we have already the pod manager in the upstream code?
Well, okay, so you're talking about so there's the OpenRMC today is mostly around specifications, northbound specifications to the rack manager. So we'll be defining the pod manager. I don't know if there's any plans to contribute code to although stay tuned for the next presentation because there may be some more on that, of work on the actual device manager to add layers of aggregation. So when I say we're working on the pod manager, I'm only speaking about specifications, not necessarily the open source contribution.
Okay, got it, thanks.
How are we doing time?
Amit Pabulkar from NVIDIA. So for the RMC to be really successful at being intelligent, right, one of the requirements that we think about is it should get access to as much telemetry as it can, right? And when a rack gets deployed, oftentimes the management network is different from the scale-up network, from the compute network, right? And then it's very challenging to make a really intelligent decision, right? And so it just becomes more of a offload engine, right, for local actions, right? And so then you would have to kind of start thinking about interfaces from each of these nodes back into your pod manager or your data center manager, and then come down, back to the rack manager, and it beats your latency argument or latency pros that you think about, right? And so one thing, it would be very interesting to understand when you talk about hierarchical intelligence, it has to be abstracted very, very carefully. Otherwise, it just breaks. Right? And I don't know if you guys have thought behind that and it's something that the group is trying to address, per se.
You can come help us address that. No, I mean, it is absolutely something, to your point, it defeats my argument that it can react quickly if it's got to go all the way up and back down. That defeats the whole purpose. So everything does have to be connected and networked in a way that allows it to truly scale the way we want it to.
So I think one big challenge is that for that software to be successful, we need to co-design a hardware at a rack level that will make that software successful. Software alone cannot be successful otherwise, because if I want a low latency access to nodes, now my rack manager needs a very fast bus, and Ethernet is not going to cut that, right? And so what is the specification of that very fast bus, and then what are the interfaces, right? So in my mind, it's a co-design problem than just a software problem.
I agree.
Okay. All right, okay. I'll talk offline.
Thank you.